Hello, welcome. We are in chapter 6, and in this video we're going to be continuing lesson 6.6. We'll be going through day 3 of this lesson. And today what we're going to introduce is the idea of what we call complex roots. Up until this point, all of the polynomials that we've been solving have had real roots. They might have been decimals or fractions, but they were all real numbers. So today we're going to talk about what happens if we get a root that's an imaginary number. So we're going to kind of talk about that a little bit here at the beginning. And this will be true that any zero that involves a square root is going to occur in what we call conjugate pairs. Conjugate pairs. So what we mean by a zero that involves a square root, that will include square roots themselves. So for example, like if our root was the square root of 8. As well as this will also include imaginary numbers. And the reason for this is because I is actually equal to the square root of -1. So if we have an I in our answer, that's actually considered a square root. And what we mean by a conjugate pair, we should know that pair means 2. So when we're talking about a pair, we're always going to have 2 zeros. And that's going to include the positive and the negative. We learned this when we were solving with square roots, that whenever we take a square root, we always get a positive and a negative answer. When we're working with these zeros, it's going to be the same process that we've already talked about. So the process of solving is not going to change at all. The only difference is that we know that we should have a pair. So if we ever get a square root as our answer, we know we should have a positive and a negative. Or if we get an imaginary number as our answer, we know we should have a positive and a negative. So the first thing we're going to do is start with kind of writing factored form when we have these types of roots, whether they're imaginary numbers or square roots. So, for example, here we have these zeros, a -2 and a 2i. What we know to be true is if I have 2i as one of my zeros, that's a positive. I also have to have -2i as a zero. And that's because imaginary numbers have to occur in pairs. We have to have a negative and a positive, even if they both aren't originally listed. So if we're going to write our factors, factors are opposite. So if we have a -2, we'll write x plus 2. This 2i, since it's positive, I would write x minus 2i. And this 2i, since it's negative, I would write x plus 2i. So again, when we see those pairs, we should always have a positive and a negative. So we should have an x plus 2i and an x minus 2i. The same thing will happen with square roots. So when I have this square root here, we also know that square roots have to occur in pairs. So if I have a positive square root of 3, I would also have a negative square root of 3 when I write my factors. Again, even if that's not written, we need to include that as a 0. And again, we know factors are the opposite. So that positive 5 we'll put as x minus 5. A positive square root of 3 we'll put as x minus square root of 3, and a negative we'll put as a positive. So again, we see that pair where we have a positive and a negative. Now, notice that this is only for imaginary numbers and square roots. I'm not adding in the opposite of 5, and I'm not adding in the opposite of -2. Those are just the same. All right, we'll do one more of these. So here we have a 6. Here, this number in parentheses is actually a complex number. We learned that complex numbers include real numbers and imaginary. When we take the conjugate would actually be 3 plus 4i. So we're going to add that in as the conjugate pair. That whole thing is going to be our 0. So when we write our factors, 6 is positive, so I'll write x minus 6. Now, when I'm writing my factor here, I'm really just paying attention to the real number. If the real number is positive, I'm going to write x minus 3 minus 4i. And here will be the same, again, because this number is positive, I'll write x minus 3 plus 4i. So notice that the opposite for this is actually occurring with the imaginary number, not the real number. So it's a minus 4i and a plus 4i, but that 3 is still a minus. All right, we'll go through just a couple examples of solving polynomials where we might get square roots or complex numbers as our answer. So this process is going to be the same as what we did on day 2, where we're going to start by graphing, and then we'll go ahead and find our factors, multiply those factors, do long division, and then solve the leftovers. So I'm going to go ahead and pull up Desmos, and we'll start by graphing this polynomial on Desmos. So I'll go ahead and graph this. X to the 4th minus 3x cubed plus 5x squared minus 27x minus 36. Now, when I look at this polynomial, I know that the degree is the highest exponent. So my degree is 4. I'm expecting 4 solutions when we solve. When I look at my graph, what I notice is I actually only see 2 solutions. Even if I zoom out, I don't see any additional solutions. I just see those 2. What that means is we only have 2 real solutions because we only see 2 of them. If I'm expecting a total of 4, but I only see 2, that means the other 2 will have to be complex. They're going to be imaginary because I can't see them. So I'll go ahead and write down my real zeros, -1 and 4. Again, I can just find those by clicking on those points. So I'll use -1 and 4 as my solutions. And then we'll continue on in our process. That step 1 is to graph and find our real zeros. Step 2 is we'll write those as factors. So -1 I'll write as x plus 1, and 4 I'll write as x minus 4. Step 3 is to multiply. You may use distribution or box method. It doesn't matter to me. This will give me x squared minus 4x. We'll multiply by the 1 plus 1x, and then by the 4 minus 4. Combining like terms, that will give me x squared minus 3x minus 4. This new polynomial that we get, we're going to use in long division. So that's going to go outside of my division symbol, and then my other polynomial will go underneath my division symbol. For long division, we're going to start by finding a factor. We'll multiply that factor, and then we'll subtract. So I'll go ahead and start with my x to the 4th. To take x squared and get x to the 4th, I would want to multiply by x squared. We'll go ahead and multiply. X squared times x squared is x to the 4th. X squared times -3x is -3x cubed. And x squared times -4 is -4x squared. Then we're subtracting. Subtracting means we're going to have to change those signs. My x to the 4th will go to 0. My x cubes will also go to 0. 5x squared plus 4x squared is 9x squared. I'm going to bring down both of the next terms. And we'll redo that process again. To take x squared and get 9x squared, we'd want to multiply by 9. So my factor is going to be 9. And we'll multiply 9 times x squared is 9x squared. 9 times -3x is -27x, and 9 times -4 is -36. Again, we're subtracting, so I'll change those signs. We do see that everything is the opposite, so those will cancel. We'll be left with a remainder of 0, which is what we want. Our last step is to solve the leftovers. These are my leftovers, this x squared plus 9. So my final step, I'll go ahead and take that x squared plus 9, and we'll set that equal to 0. Now, if we subtract 9, 0 minus 9 will give me negative 9. And then to undo squaring something, we would take the square root. Now, we've learned how to take the square root of negative numbers. This is not something we can type on our calculator because our calculator will give us an error. But if I think of positive 9, I know the square root of positive 9 is 3, and the negative we would make an I. So that actually becomes 3i. And remember, what we just talked about is when we take and we get an imaginary number, we could have a positive or we could have a negative because those will occur in pairs. So my pair of imaginary numbers would be positive 3i and negative 3i. And that gives me my final two solutions. We'll go through one more example of complex roots. Again, we'll start with our degree. Degree is the highest exponent. That's a 4, so I'm expecting 4 solutions. I'll go ahead and graph this on Desmos. And we're looking for the x-intercept, so we're looking for where this crosses the x-axis. Similar to our last problem, I only see 2 points. And if I only see 2 points, that means we're only going to have 2 real zeros. And if we only have 2 real ones, that means the other 2 will have to be imaginary. Those zeros that were on my graph were negative 5 and 1. So I'll go ahead and write those down. That's step 1. Step 2 is I will write those as factors. So negative 5 will become x plus 5, and positive 1 will become x minus 1. Step 3 is we'll multiply those factors. So I'll do x times x, which is x squared. X times negative 1 is negative 1x. 5 times x is 5x, and 5 times negative 1 is negative 5. Combining like terms, that will give me x squared plus 4x minus 5. This will go outside of my long division symbol, and then we'll put our other polynomial inside of the long division symbol. And we'll go through our process of long division. To take x squared and get x to the 4th, we would need to multiply by x squared. So we'll multiply x squared times x squared is x to the 4th. X squared times 4x is 4x cubed. And x squared times negative 5 is negative 5x squared. We'll change those all to the opposite, and we'll combine. X to the 4th minus x to the 4th is 0. 4x cubed minus 4x cubed is also 0. Negative 1x squared plus 5 would be 4x squared. And we'll bring down our last 2 terms. To take x squared and get 4x squared, we should be multiplying by 4. So we'll multiply 4 times x squared is 4x squared. 4 times 4x is 16x. And 4 times negative 5 is negative 20. We'll change those to subtraction. Those will all become opposite, and they should all cancel, so we'll get a remainder of 0. Last step, these are my leftovers, x squared plus 4. So we're going to take x squared plus 4, and we'll set it equal to 0 to solve. I would want to get x by itself, so we could subtract 4. 0 minus 4 is negative 4. And then to undo squaring something, we'll take the square root. Again, similar to our last example, this is a negative number, which we've learned how to take the square root of. So the square root of positive 4 would be 2, but we would put an I because it's negative. And again, we just talked about imaginary numbers should occur in pairs, so we should have a positive and a negative. So my last 2 solutions would be positive 2i and negative 2i.